The Sun, a magnificent celestial body that has fascinated humanity for millennia. It's a giant ball of burning gas, primarily composed of hydrogen and helium. But it's so much more than that. It's a dynamic, ever-changing sphere of energy. It's the center of our solar system, holding everything from the smallest asteroid to the largest planet in its gravitational embrace. It's the source of our light and heat, providing the essential energy that sustains life on our planet. Life on Earth wouldn't exist without it. Plants rely on sunlight for photosynthesis, which in turn supports the entire food chain. The sun is incredibly powerful, capable of producing solar flares and coronal mass ejections that can affect space weather and even disrupt communications on Earth. It's hard to imagine its size and energy. The sun's energy output is equivalent to billions of nuclear bombs exploding every second. But let's try to grasp its immensity. The sun is about 109 times the diameter of Earth. Imagine over 1 million Earths could fit inside the sun. That's how big it is. That's how big it is. Its sheer size and mass dominate the solar system. The sun is not a solid ball. It's a complex structure with multiple layers. It's made of layers like an onion. Each layer is different, with unique properties and functions. Each layer plays a crucial role. These layers work together to produce the energy that radiates into space. They create the star that sustains us. The core, where nuclear fusion occurs, generates the energy that eventually reaches us as sunlight. In this journey, we'll explore the sun's secrets. From the core to the corona, each part of the sun has its own story to tell. We'll travel from its fiery core to its outermost layers, uncovering the mysteries of our closest star. Prepare to be amazed by the power of our very own star. The sun is not just a source of light and heat, it's a dynamic, powerful force that shapes our solar system and influences life on Earth in countless ways. Let's begin our journey at the heart of the sun. The core is the very center of our star, a place where the most intense and powerful processes in the solar system take place. This is the core, a place of unimaginable power. It's a region that holds the key to the sun's energy and life-giving light. Temperatures here reach a staggering 15 million degrees Celsius. To put that into perspective, that's about 27 million degrees Fahrenheit. That's hotter than anything we experience on Earth. Even the hottest places on our planet, like volcanic lava or the core of a nuclear explosion, pale in comparison. The core is where the sun's energy is generated. This energy then travels outward, eventually reaching us as sunlight. It's a giant nuclear reactor, but unlike the reactors we have on Earth, the sun's core operates on a scale and intensity that's hard to imagine. It's constantly fusing hydrogen atoms together. Every second, millions of tons of hydrogen are converted into helium. This process is called nuclear fusion. It's the same process that powers hydrogen bombs, but on a much larger and more controlled scale. It's what makes the sun shine. The energy produced in the core radiates outwards, giving us the light and warmth that sustain life on Earth. The core makes up only a small part of the sun's volume, but it's incredibly dense. In fact, it's the densest part of the sun. It contains almost half of the sun's mass. This means that despite its small size, the core is the heaviest part of the sun. Imagine squeezing all that matter into a space the size of a small city. The density is so extreme that a single cubic centimeter of core material would weigh over 150 grams. That's the density of the sun's core. This incredible density is a result of the immense gravitational forces at play. This incredible pressure and heat are essential. They create the perfect conditions for nuclear fusion to occur. They create the conditions for nuclear fusion to occur. Without these extreme conditions, the fusion process would not be possible, and without nuclear fusion, the sun would cease to exist. It's this process that has allowed the sun to shine for billions of years and will continue to do so for billions more. The sun's core is not just a source of energy, it's a time capsule. By studying it, scientists can learn about the past and future of our star. Through advanced technology and observation, we continue to unlock the secrets of the sun's core, gaining insights that help us understand not just our own star, but stars throughout the universe. The sun's core is a testament to the incredible forces at work in the universe. It's a reminder of the power and beauty of the cosmos and our place within it. Nuclear fusion is the heart of the sun's power. It's the process that fuels our star. It's a dance of atoms, a delicate balance of forces. Imagine hydrogen atoms, the simplest elements in the universe. In the core's intense heat and pressure, they're in constant motion. They collide with incredible force, and sometimes they fuse together. When hydrogen atoms fuse, they form helium, a heavier element. This process releases a tremendous amount of energy. It's this energy that powers the sun. The sun converts millions of tons of hydrogen into helium every second. It's a mind-boggling amount of energy, and this energy has sustained the sun for billions of years. The energy produced in the core doesn't stay there. It begins a long journey outwards. The first stop is the radiative zone. This vast region extends outwards from the core. Think of the radiative zone as a dense forest of atoms. Photons, tiny packets of light energy, try to escape this forest. They bounce from atom to atom, constantly being absorbed and re-emitted. This journey through the radiative zone is slow. It can take a photon hundreds of thousands of years to escape. It's a chaotic dance of light and matter, but eventually the photons make their way to the edge of the radiative zone. From there, they enter a new region, the convective zone. Section 5, the convective zone, where the heat rises. This is one of the most dynamic and fascinating regions of our sun, a place where the energy generated in the core finally begins to make its way to the surface. The convective zone is a region of turmoil. Here, the sun's energy is in constant motion, creating a chaotic and ever-changing environment. Unlike the radiative zone, where energy is transported by radiation, in the convective zone, energy is transported by convection. This means that hot plasma rises and cooler plasma sinks, creating a continuous cycle of movement. Think of a pot of boiling water. Just as the water bubbles and churns, the plasma in the convective zone moves in a similar way, though on a much grander scale. Hot plasma rises from the bottom of the convective zone. This plasma is heated by the energy from the sun's core and carries this energy upwards. As the hot plasma rises, it carries the sun's energy towards the surface. This process is crucial for the transfer of energy from the sun's interior to its outer layers. As it cools, the plasma sinks back down. This sinking plasma is then reheated and rises again, creating a continuous cycle of movement. This creates a constant churning motion. The convective zone is never still, always in a state of flux as plasma rises and falls. These churning movements create giant cells of plasma. These cells are enormous, some spanning thousands of kilometers across. Some are as big as the Earth itself. Imagine a single cell of plasma the size of our entire planet, constantly moving and changing. The convective zone is the final layer of the sun's interior. Beyond this layer lies the sun's surface, where the energy that has traveled from the core finally emerges. It's from here that energy finally breaks free. After its long journey from the core, the energy reaches the surface and is released into space. It bursts into the solar atmosphere, a place of even greater wonder. Here, the energy interacts with the sun's magnetic field, creating spectacular phenomena such as solar flares and coronal mass ejections. Section 6, into the atmosphere, the photosphere. We've reached the sun's atmosphere, a region of incredible activity. The first layer we encounter is the photosphere. This is the sun's visible surface. When you look at the sun, never directly of course, you're seeing the photosphere. It's a layer of glowing gas. It's about 500 kilometers thick. The photosphere is where sunspots appear. These are cooler, darker regions on the sun's surface. They're caused by the sun's magnetic field. The photosphere is a dynamic place. It's constantly changing. It's the stage for spectacular solar events. These include solar flares and coronal mass ejections. Section 7, the chromosphere, a layer of color. Above the photosphere lies the chromosphere. This layer gets its name from the Greek word for color. It's visible during a total solar eclipse. The chromosphere is a thin layer of gas. It's much hotter than the photosphere. Temperatures here can reach tens of thousands of degrees Celsius. The chromosphere is home to a variety of features. These include prominences, which are giant arcs of gas. They extend from the chromosphere into the corona. The chromosphere is a place of intense activity. It's constantly changing. It's a key area for understanding the sun's magnetic field. Section 8. The corona, the sun's crown. The outermost layer of the sun's atmosphere is the corona. This is a vast ethereal region. It extends millions of kilometers into space. The corona is incredibly hot. Temperatures here can reach millions of degrees Celsius. That's much hotter than the sun's surface. The corona is a mysterious place. Scientists are still trying to understand why it's so hot. It's thought that the sun's magnetic field plays a role. The corona is visible during a total solar eclipse. It appears as a pearly white halo around the sun. It's a truly awe-inspiring sight.
Like and subscribe to start your journey today.